Okay. Yeah, I'm obviously running a little behind. Just realized the camera is... pretty wonky. This small help? Really? Alright. Well, that's another problem to think about. Let's try to keep moving so we can actually get started. Okay. Yes. We're finally almost pretty much nearly ready. Alright. Welcome. Good morning. Thanks for hanging in there. If you were trying to watch this a few minutes ago, if you are new and don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. I usually work on CircuitPython stuff on my stream, and I usually stream around this time each week. I try to start at 10 a.m. Central Time. I'm a little bit late this morning, on Saturdays, I should say, 10 a.m. Central Time on Saturdays. I'm a bit late this morning, but I do try to stream around this time each week, working on CircuitPython stuff. If you don't know what CircuitPython is, you can learn more at the main website for it, circuitpython.org. It's basically a version of Python that runs on tiny computers, like this e-ink one here. The way it works, typically, you plug it into your computer with a USB cable. It shows up like a thumb drive, and then you can edit a Python code file on that thumb drive. And when you save it, it will execute the Python code for you inside of the microcontroller that's on these devices. I would flip this over. I don't know how long it's going to take to actually show, but inside of here is a microcontroller. There's actually a computer in there that can execute the Python code for us. So that is the high-level version of what I'm working on. In specific, today we are going back to what I started last week, which was trying to make this dithering work. It'd be a bit of a shame if the camera never gets any better. They're like, let's check into this for just a minute. I don't want to obviously spend the whole stream working on VLC, but it would be nice if we can get this, and this is kind of stream related, because basically I got a new camera for the stream. So this is my first time using it. VLC capture device settings. Can we like lower the frame rate or resolution or anything? Can I go to the page without the pop-ups? 1080p OBS. So I'm not doing, well, I'm streaming with OBS VLC. Media capture, direct show. So maybe on the page that I have already passed. Output modules. I don't know if it's gonna be Linux. Don't use OpenGPL. OpenGL. This doesn't tell me what to do though. Turns out default is not an answer. We changed the output and restarted VLC. We can change the output. Modules, video, tools preferences, video output. There's no output. Here's output. There's a and they said X video output was better for them. So the tricky part about this though is like, what's up, C Grover? The tricky part about this is I could just accidentally wreck the stream. I don't really want to do. There's so many. They said X video. I'll try it. I'll save it. So the problem is though, I think before I was having trouble where I couldn't. Oh, I hope this works. I couldn't. This didn't work when OBS was running, basically. Work? Oh my goodness, it worked. Okay. But it's no better, really. Okay. Frame rate right there. So this says device name. Not very helpful other option. So if I click advanced options, which I assume is advanced options, why does this go back to video 0? This is dev video 4. Guess I would want 4 here. I mean, I suspect this is part of my problem. I definitely do not need 60. Did I just change that? I think it changed because I mouse wheeled. Primary language, that was then. Colors. There's no like resolution per se. There's aspect ratio. There is width and height. No better. Okay, I do not want to mess with it too much longer, but I'm gonna try width and height down some. What is 720p? Is that 1280 by 720? What's the size of 720p? 1280 by 720. Just gonna close and try again. Device, advanced. Do I need to set it here and out there? I'm not sure, but. Yes, because it doesn't set here. Eyes. It's maybe slightly better. It is actually maybe slightly better. And with that in mind, I think I actually want to push it even further. Sorry, I know this is not CircuitPython or particularly interesting, but it is a thing I gotta do with get the new camera ready for streaming, essentially. Doesn't like that. Oh, okay. Wait a minute. Really about the same as the 1280 was. And then did this thing save? Did really make it? Okay. So there's a bunch more of those I could try. Yeah, but again, I don't want to just make the whole stream mess with VLC. So let's hope that that's good enough for now. The good news is we're not like doing anything that requires a fast frame rate because we're just looking at this e-ink screen. It already takes several seconds to refresh itself, so that's not true actually. It takes about a second, I think, to refresh. It's not several seconds. I'm thinking of the color one is really the one that I have in mind, but that's not this. Let's knock the camera way off kilter. You do have to wait forever to see. Back to, I need to plug this in. Okay, so getting back into what I actually want to work on instead of the camera. Last week I started this 50-cent dithering quest here to try to get this picture, which I have, right, I'm not used to going to VLC for the camera just yet, so the web. This will take however long it will take to update, but I have mag tag here with 50 cent. In this particular picture of 50 cent, I have dithered it on my computer down to 4 colors because the mag tag supports 4 different colors, black, white, and then 2 grays. And I'm trying to make that possible to do dynamically in CircuitPython. Because I did this in PIL, but I would like to be able to do it in CircuitPython. And we started this last week. We did not have success, but I got my head wrapped around Microlab and importing to arrays and exporting from arrays to bitmaps and a bunch of other stuff, which I think ultimately is going to be good. I basically had to know all of that in order to have a chance of making it work, even though we didn't actually get there last time. How fast this will. One thing I noticed is I have corruption on this drive. It's not like broken, not working yet, but I assume it's gonna be at some point soon. Start by taking a backup of it. Yeah, so this takes a long time to run, actually. It is running, and it will maybe update the screen when it's done. Once it does that, we'll take a look at it. Oh, it's still going. First 2, 2, 3. A couple things that I learned, though. So for anyone who watched the last stream, I did do a little bit more off-stream. I think either Sunday or early in the week last week. I don't remember exactly when I did this, but I wasn't on the stream when I did it. I figured out a little bit more, which is that the colors we are getting out of the bitmap are in 565. which makes sense because that's what display.io uses. Kind of as a baseline, like it hides it to an extent from the user. The user generally sees like 888 color with either RGB, tuples 0 to 255 or hex, 6-digit hex 0 to FF for each of the three colors. But underneath, inside display.io is more typically going to 565, and there's color converter, which essentially does it kind of automatically. So that was one thing that I did not take into consideration last week, was that the colors were getting out of the bitmap, because like roughly the process of the dither here is get data out of the bitmap, run it through this algorithm, and then ultimately try to put it back into the bitmap, which is also partially this chunk of code. That's kind of the high level, like get the data out, run the dithering algorithm on it, put it back in the bitmap, and then that's what we're trying to do ultimately. And when we were getting it out of the bitmap, we were actually getting 565, and last week the code that I was trying was not accounting for that at all. So that definitely was throwing everything off. I have now changed that to 8 bits, but the other thing is we're also in grayscale, so we don't actually care about all of the color channels. So I ended up making this function that kind of just looks at the red and ignores the other color channels, since those are the same for grayscale. So that was another thing we needed. And I learned this all by basically looking at output. I should open up the other one, but I basically added extra print statements to the original implementation of this algorithm. To see like what values it actually had at every step of the process, because it's basically doing the same process. Get the data out of the bitmap, run the algorithm on it, and then put it back into a bitmap. And I just added a bunch of print statements to where I could see what it was getting out, what those numbers look like, what it was doing to them at each step. So that's how I learned that. The other thing, which I was not accounting for at all last week, was paletization, like indexing of the colors. So this algorithm by itself doesn't know about indexed images, really. It's not dithering down to an index in a palette. It's dithering down to RGB colors. It's taking an RGB image, in our case grayscale, and it's taking it down to a certain number of colors, but it's still RGB colors. It's not 0, 1, 2, 3. So that was another problem, which is what this here is trying to solve. This should be loaded now, and you could see like even the latest attempt is not actually working. There's just like static fuzzy stuff there. So that was one problem, was like we need to, I mean, the solution I went for most recently was turn it into an indexed image. Actually have a different idea for maybe a different solution that we will look at today. So that was one problem as well. And I think actually where I'm going to start, so I've learned a lot working on this code. But I almost want to, I'm thinking actually, that might toss it and start over. It would be a shame to lose some of the stuff like array blitz. So, okay, let's try one thing here. Instead of this indexing, so if all of this works correctly, then we will have loaded the data into the buffer and then normalized it down to between 0 and 1 instead of between 0 and 255. And we only have one value per pixel. Again, because it's grayscale, we're basically just only paying attention to one color channel. The original code also was handling multiple color channels, but I think it was kind of using niftiness of numpad to make it seem like it wasn't having to do any extra work, but not 100% sure. So if this is working correctly, we would have our data here going through this. This is the algorithm. It creates CR, color array, I think is what this one was meant to be. Array shape. So, I want to like be able to see better what it's got currently. So I don't think this is working quite right. We end up with only two different colors, basically. We're just getting 2 and 3 and 2 and 3 and 2 and 3 over and over. We're never getting 0 or 1 in the indexed values. So for now, I'm gonna just take out the indexing. And I would like to print more of this. I don't know where these are printing from. So this came after indexing. I wish I could print the whole row. Can I turn it into a list and print the whole thing? I know it's a lot of data, but I really want to see if there's like literally no other zeros and ones. And then we need to try to tell if the problem is that we got bad values up here, probably suggesting we got bad values straight from the beginning when we loaded it, or do our values get bad after we try to bring them back up? This was just printing 10 rows of CR, which is loaded up there. Okay, so let's just print rows of this, but if I list this, will it show me the full thing? And then, truthfully, the bitmap is just, it's gonna be all wrecked. I don't know. It definitely won't show correctly. But I am hoping we can at least see the printout. I assume it will probably raise an exception of some variety because we're giving it wrong. Good. It does print the whole thing. And we do just not, it's not, we don't have good values. Those should be basically pixels from the top. There should be something closer to 0 where the dark parts of the hat are. And those start on the second row, so those should be in there somewhere. But we're not actually getting that. I wonder, it almost is like we're repeating the same row over and over again, although I don't think, well, okay, so it did draw actually, but it does not draw anything useful. What if we look at the data before it gets to CR? Maybe in the jump from, so this has R, it's making out of buffer shape length. Let's print some of it. Not print this, and instead let's print R here. This should be loaded buffer. And this is before the dither even, so that's fine. Let's do that and let's see what we have. I'll just do the first 10 again, list. What I'm gonna do though, one more thing here is just extra new lines to make it a little easier to see where one begins and one ends. One thing though that I am tempted to do is try none of these are close to 0. Some of these should be closer to 0. 0 would be black in this case. And close to 0 would be dark gray. And we should have those, but it's not working. Let me just make sure. So we're reading 50% original RGB bitmap, which is this. Yeah, so we definitely should have is doing all of this in one step like somehow making it so that we just have the first row repeated over and over? Is it actually repeated? So in my terminal, it goes basically 2.5 rows. All the way to here is the same value, 803922. Yeah, so this is just repeated the same exact row over and over again. Okay. I'm wondering if this is not syntax that we can do in CircuitPython all the way. So I'm wondering why I got no music on. Okay. That means this is gonna be all whack, but that's fine. These will be the non-divided values. So these should be between 0 and 255. And it's basically the same problem. It looks like at a glance. This one goes to here because they're shorter. Okay, let's go back another step and look at buffer. Like, do we ever get an image that seems correct? Or maybe option B, can you not... I'll admit to not using NumPy arrays very much. Like, I assume you can index them within ints like this. Is that, maybe that doesn't actually work with, I mean, surely not, right? Surely that works correctly. But maybe that's something to look at, is does that not work for some reason with NumPy arrays? Does it only want to be iterated instead of square bracketed, or I don't know. So this one is a list of lists. Yeah, that's fine. I guess the other one was too, actually. I do also have this reversed, which doesn't really make sense in my head. But I did that because it seemed like it had the wrong side at first. No, this is still just repeated data. It is again formatted slightly differently, so now it changes here. But it is still just 10 rows of the same. Hmm. Are we... I mean, we basically just need to start checking things that seem obvious, but... yeah, okay. Seem obvious. I do have to use strings, so that's going to take forever to print, but... and try to see if it's... doesn't do anything. Not working. Hmm? Did I not see? Running the latest one? Okay. So this is definitely backwards, which makes sense because it says reversed. Be honest, remember exactly 100% what led me to do that, but I basically became under the impression that I was looking at the pixels from the bottom of the image instead of from the top of the image, so I reversed it to account for that. Exactly sure why I was convinced of that, though, it turns out. Okay. Maybe I thought that because this can't. Annoying. I want to be able to scroll in, but have this not be the literal bottom of the pane, but can't do that. That's a thing you can do in GIMP, but not here. So I think what happened is I thought I was looking at the bottom rows of pixels because this is dark, and then there's some light, and then some dark, and then some light, and then some dark. And presumably we have like dark, darker, light, dark, getting lighter, still pretty bright, getting darker, getting light again. I mean, that really looks like the pattern at the bottom of the screen, does it not? Like, we have sort of 3 chunks of lightness. Yeah, so I think it is the bottom. It's the bottom because when we square bracket a bitmap, we get bottom left. When we square bracket a bitmap, we get bottom left pixels based. I'm pretty sure. Well, I think I was right, actually. I think this is reversed because this is anchored to the bottom left. This starts from the bottom left when you square bracket the bitmap. That's my hypothesis right now. We're going to validate because I'm in validate everything mode since I really don't understand why we keep getting those repeated rows. Are these... well, let's do this first. Let's do this. And then let's check if what we have is repeated. Maybe somehow we're just getting repeated rows and we either get the top row repeated or the bottom row repeated, and maybe we're never getting anything other than that. That could be. Palette. It's a little bigger. So this should be a black square. I need to call display refresh, I think. It's too soon. Okay, so the problem is the whole display is black and we drew a black square on it. So instead of filling with black, let's fill with white. It's getting worse over time too, because it's like way behind now. It finally updated. Okay, so we have a white square. And if I go bitmap 0 equals 1 instead, which will make it closer to black. Let me actually do 0 0 0 1 1 0 and 1 1. Let me make a little 2x2 square. Hypothesis is that square gets cut out of the bottom left. It's not, it's the top left. Oh boy. It's the top left. Okay. I don't know. That's weird. These look like they're from the bottom, but okay. They are repeated, though. I can actually just eyeball it and see. These are always repeated. So it seems like we have a bunch of copies of the same row instead of the whole image, whether it's the top or the bottom or completely random data. Notwithstanding, it does seem to be just repeated for some reason. And I'm not sure that I'm understanding why. So let's just go through the logic here. Row is a list of zeros that is the size of the width of the bitmap. Buffer is an empty list. For I in range of the height, add row. So that's going to fill out buffer as a two-dimensional list filled with zeros. And it should be width and height matching the bitmap at that point. Then it's going to go y in range of height, x in range of width. It's going to get this value here. So maybe the logic in this is broken. Let's try to, well, let me make sure that, let's check if they're actually all the same or not. How can we do that? Python, check if all items in list are the same. Use a set. That's not what I mean. Well, Okay, that works actually, because we can check the list. Check the length of, and it will be 1 if they're all the same. Print set length, set buffer, buff length. So turn the buffer into a set, which will inherently remove duplicates, and then tell me how long it is. The idea being, if it's only 1, then we know that every row was repeated. It crashed. Can't do that. I don't know if that's a CircuitPython problem or if that's because we have a list of lists it doesn't work, but in any case it doesn't work. Supported type hash for list. I just want to know if they're all the same. I think if we okay. Okay. Same count equals 0. For I in range, length of buffer. For Y in range, length of buffer. If Y, if buff Y is the same as buff 0, same count plus 1. Definitely do not do this. Where did it? So I just overrode our loop to 10, but that's fine. Do that for now. Same count. So if that's the same as the height, then every row is the same. Height's like 202. 102. Okay, every row is the same. So now, is this breaking it? Keep that on, actually. Is this somehow giving us bad values, or are we getting bad values directly out of here, which would be perhaps more problematic? Are we sure we're calling this on the image we think we're calling it on? So photo is from the one that's loaded from this. Okay. I think it should be fine. Okay. Wish this print both was here and wasn't here at the same time somehow. So I know this will not work for the dithering algorithm, but if we just take values out of source bitmap and put them in buffer, what do we end up with? And what do they look like? They're all the same still. But they're bigger numbers. Because they're like hex values. They're 565 hex values. B1A6, if we go to a... It does want the 0x. Gray. Okay. It still feels very much like it's the bottom row to me, and I don't understand why. But at the end of the day, like, if I never understand why and I just put reversed right here and it works, I'm fine with that. The bigger problem, though, is why repeat? Why is it repeated? Could I have not done this? Shader. Is it gonna be, what kind of pixel shader is it gonna be? Alright, let's try looking at this. What does this look like? Let's turn this off, because I am still fairly new to this. I don't actually know what it does fully. I mean, I saw it visually, and it shouldn't affect the bitmap itself, so I don't think it would make any difference to what we're doing, but just to try to, like, rule out only, try to get down to only stuff I'm, like, really familiar with. So photo, TG, let's not put dithered anymore. Let's only put photo. It can do all the rest of the stuff, that's fine, but we're going to be looking at photo tile grid, which comes from photo bitmap, which is what we're trying to dither, which is where we're pulling the pixels from, and they seem the same each row. One more thing I want to do, though, is I want to know print type photo pixel shader. Okay, it'll take a really long time. Yeah, it's finally done. And we just wait for VLC. Okay. I mean, this is definitely not, like, repeated. This is definitely a good copy of the bitmap. It has different values in the pixels of every row. I am super perplexed then how all the way back here we end up with a buffer that is filled with the same row over and over again. Are we... this is bad, isn't it? This is bad, I think. I think we're getting wrecked by, like, references or whatever, right? So we're adding the same row. I'm adding the same row over and over. So what I'm ending up with is a list of references pointing to the same list. I'm not ending up with a list of lists. I'm ending up with a list of references, and all the references point to the same list. And the reason why it's the bottom row is because it gets to the bottom of the for loop. It's updating the same list every time, and when it gets to the bottom is the last one it did. So the crux of this is we need to be making new list every time here. We do not want to just use the same one. I think that's my next hypothesis. That's a painful lesson in reference versus value, huh? I did not know that about... for some reason, I thought that was going to be creating new ones, basically. Yeah. So now there's only one row that is the same as the 0 row. Okay, so now we just need to basically put back everything that I have taken out so far, while I slowly descended into madness trying to figure out what was going on. So for one thing, we definitely do want the grayscale. We definitely do need to convert to 8-bit. We do need that. We do... I think we can get rid of these for now. What else did I undo at this point? I've done so much. So we have R. We loaded that from buff. Luckily, I let it just keep doing its thing. So for the most part, it actually just went and did everything. We didn't do the indexing. Maybe I should do the indexing. I think we should do the indexing because the latest version of the code is expecting the indexing to be done. But I also have another idea in mind. It might be nice to not actually do the indexing. So, but let's worry about that later. We need to go back to showing the dithered one so that I don't fake myself out by looking at the one we didn't actually manipulate. Save that and see how it goes. And this takes forever to run, so get to watch for a minute here, and then another minute while VLC catches up. So yeah, at some point, we'll want to optimize. I mean, like right now, we're looping the pixels, I think, multiple times at this point, so it is very slow. Oh, interval, that's not going to help. We're going to need to take that out, actually, otherwise it's never going to end. Actually, that's kind of wrong because... has way more than 4 values. Okay, it finished, and it did something actually kind of hilarious. There's more than 4 different values here. 65, 90, 123, 131. That's already 4 right there, but there's 139, 148. I took out the divide. Which probably broke the dithering. Yeah, we need to put that back. It's letting us? Yeah, so it's like Ninja 50. We have only the New York of his Yankees hat. It's like really funny to me for some reason. I'm not sure why, but it's kind of interesting. One of my favorite things, I will say, like one of the things that draws me to graphics programming is when it's broken, it's often broken in interesting ways. I guess I'll leave this because realistically it shouldn't print that much, actually. It printed a lot that time because I forgot one of the mathematics steps that came before it. And that changed the value of a lot of things. But I believe it should not actually print that much. I basically put that else there as a, like, this should never happen, but I want to print if it does so that I will know that something has gone wrong. Now, speaking of, okay, but there are at least only 2 values. I'm seeing 0 and 84. Is doing it a lot though. Seeing all zeros and 84s. I think we're in better shape than last time, but let's see. Oh! Oh, look at that! Look at that! I do believe we are getting much closer. I think that's almost correct. I'm going to pull it out of frame. I know you can't. Yeah, so this is totally using at least 3 colors. I'm not sure that it's using all 4, but it's using at least 3. And you can see here we have random 85s, which would definitely not work in the palette. And I think this is a problem of rounding, basically. So our palette has black at 0, yes? Yeah, okay, so 0 is working. One worry I had was, like, does 0.0 count as 0 or not? And yes, it looks like it does. So, yeah, I will say it's not that it should never print, actually, because in my logic I have only the non-zero ones. Let's do elif int val equals 0. Set it like it's already 0, but whatever. We'll turn it into an int instead of a float. And then I think the other issue is rounding. You can see here, like, theoretically, this dithering is trying to get it down to 4 colors, but because of the float math in CircuitPython, and we're converting through to float 32 down to int 8, the way it works out, we're actually ending up with sometimes 2 numbers instead of 1. They're right next to each other. And I believe the same thing has happened here, right? Because I had 85... and we're seeing there's some 84s now as well. So I think due to the rounding that occurs when this gets multiplied by 255 again, and the division of when it happens above and divides, those are leading to, like, sometimes they're off by 1 when it gets converted. And I know this is not a general solution for that, but I think it should get this picture working. And any picture for the e-ink screen. Any picture for the magtag screen, I should say. But we would potentially still have more work to do when it came to dithering for numbers other than 4 colors, and potentially for dithering to palettes other than the magtag palette. But I think, maybe, fingers crossed, maybe we might actually get what I consider the correct looking picture of 50 coming out of this. Which is basically, it should look the same as the one that I dithered with PIL. Which I think was this one, but is currently on vacation to Asia. Intval 84. Why? What? Did I just added that? Oh, I didn't need to change it to in. I think I made it equal to a set, right? Yeah, this is wrong. In. Stop that. Start. It's gonna be refreshed too soon, maybe. Okay. I gotta get this figured out. So I'll have to spend some time off stream rolling through different settings or searching around online, because, like, it's super delayed. VLC, let's say Linux VLC camera capture, very delayed. Caching. Live capture caching in the advanced preferences. Set the video input to MJPEG. Tools preferences input codecs advanced live capture. Right still. I feel like it's too dark around his eyes. What does this use? Oh, this uses the broken one. Gonna work. Yeah, that feels too dark over up in his, like, I mean, it's under the hat. It is in the shade, but oh. Okay. Probably need to just format, honestly. Oh my goodness. Okay, let me take a backup actually while I thinking about it. I know I did one earlier, but given the fact that we're clearly experiencing some irregularities with the file system, let's call them. Ooh. Oh. 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 I just, oh. Uh. The old number 2 there. All right, code 50 cent. I mean, I don't think this will work, but I am just wrong. It totally works. I mean, can I trust that the image is not corrupted? I'm not sure that I can trust that. Okay. It's definitely, okay, it's definitely lighter here though, right? It's definitely, I feel it's definitely different from the one we were just looking at a second ago. Yeah, there's some dark gray. So there's a little bit of dark gray in his like brow. There's a little bit of dark gray in his brow on this one, which is the one that was dithered on the PC. And if we get back to this one, which it will take very long time for it to be there, but I'll look very closely again and we'll see if there is, because I think it was not there. I think it was only black in there. While we are waiting, since we are waiting, why don't I see if this is a thing I can do? Tools, preferences, input codecs. In the advanced, which doesn't exist. Nice, nice, nice. There is all advanced, okay. Then do find live capture. There's no live capture. I don't get the sense that I'm in advanced for input codecs, though. I get the sense that I'm in advanced for all of VLC. And that this is not necessarily tied to the page that I'm on. Processing level? Higher levels require more CPU but produce higher quality pictures. That's maybe something to turn on, turn down? The video input to MJPEG. Okay. Anyway, this has drawn. Yeah, there's totally no. There's no dark gray. It's not using dark gray at all. And this is still wrong. Did this not save? I don't know. I don't think it. It doesn't feel like we are running the right code. Doesn't seem like it's saved, right? Because if intval is in the set of 84, 85, do this, elif, else, print intval, and it printed intval and it was 84, but it absolutely is in the set. So I don't think it. I kind of don't trust that we're looking. I kind of don't trust that it ran what I'm looking at here, basically. But it saves okay. Usually when the drive is very unhappy, it will like fail to save. Doesn't look like it reset itself though, which is suspect because it doesn't. I don't have boot pi turning that off, so it. If it would have seen a difference, it would have reset. I'm just gonna reset button, see what state we come back to in a minute. But I think we might be. Pretty much all the way towards wanting to do the format. I'm starting to suspect that the. Yeah, this is still wrong. Starting to suspect that this is not. That the flash is actually out of whack. Oh, the type is color converter. I don't think I ever even looked at that. While this runs, I'm going to run to the restroom real fast. Take it a minute anyway, so BRB. Oh, I think that's it. Yeah, that's it right there. It's like sometimes it's slower than others. Okay. My goodness, we made it. I've dynamically dithered this image of 50 Cent. And it now looks the same as the one that was done on the PC. It's not upside down. Learned my lesson about references. Do not add the same list to a list over and over unless you want the universe to not make sense. Noted. Actually just had this idea. I'm pretty sure the camera itself is 30 FPS. So is there any sense in trying a lower FPS? It's like theoretically, if we're setting it to 30, like that's the fastest the camera can go anyway, as far as I understand it, this camera. And my hope is that a slower FPS would mean less processing power and thus ability to keep up much better. Not really. I don't know, it seems basically the same to me. Where was MJPEG is what that thing was saying. It's saying launch it from the command line. I'll take that off of the screen. Sorry, that's a bit. I mean, it looks really cool. Back to my thing before about, and it is also way faster. So back to my thing before about graphics programming having the most fun, like being fun when it goes wrong. It's interesting to look at when it goes wrong. What if we just did this without the live caching thing? Is that the live caching's problem or the MJPEG's problem? That is the MJPEG's problem. Ah, well, that's really a shame because, like, it's obvious, like, it's way better on the everything except for the spazzing out completely front. Hmm. All right, well, that is something to keep in mind. That got me pretty close. If we could just get it to not spaz out, I think that would be basically perfect. Here's video standard. MJPEG is not in this list. I don't know if MJPEG is a video standard. And I have no idea what the camera is using, honestly. Does all versus undefined make a difference? Video input chroma format. Okay, there's that. So there is pressed input. There's M. So this list lists both MJPEG and M-JPEG. Is there any reason to believe that one or the other might be better? JPEG? So, I'm not really sure that the size is making a difference, honestly. Or the frame rate. So that could possibly just be the 15 FPS that I set. I feel like this is a little bit better. Maybe we could go back and try 30. I know I kind of just started going back to this is a VLC configuration stream, but I did actually get the thing done that I wanted to make work. Now I feel a little bit motivated to tinker with this some more. I should figure out that command line though. If I can do all this from the command line, it would be nice to just have, I could have a script that's like open camera, right? I could just run that and it would always be the exact right settings. Sure if I need to, oh, this is not saving. That didn't save anything. Yeah, I did do that before. Oh, 30 is still slow. Much slower, in fact. If we did this with m-jpeg, I was not getting any spazzing out on that one. Maybe this... Oh, it doesn't like it. Buffer prevented something too late. Not working. Oh. Hmm. No. Doesn't seem better. Okay, I'll go to the best one that I have found so far and then quit messing with it for now. Which was, I did this, I did m-jpeg here, I did 1280, 720, and I think I did either 15 or 10 here, I don't remember for sure. And that's like, not bad, could be worse. Okay. So now I think the questions are like, how do we make this reasonable to use? Because it does take way too long to be reasonable to use, I think. And we have basically... So we have a few things going on here that's making it much slower than it could otherwise be. Let's profile this a little bit. So let's say start loading time equals time.monotonic. Finished loading time equals time.monotonic. Print loading took finish minus else here. Finish took that. So how long does it take to load? And then how long does it take to do this algorithm? Print, let's say starting dither time. Finished dither time. Print dither took. Okay, let's run it that way and see what we're actually looking at on each step. We also have additional prints, which we could get rid of that would make it a little bit faster, although we're not printing that much now. We have like 10 or whatever here. We're not printing like every row or every pixel or anything, so it's not really going to be that big of a change there. So loading was actually quick. Loading actually took less than a second, which I think is like fine. I mean, that's on the slow side for like most computer software stuff, but on a microcontroller, I don't know, 1 second to load an image, it's not terrible. But the dithering is taking 30 seconds. Oh, and then the indexing also, it looked like took a little bit there. I didn't even do indexing. Start indexing time. So one thing we might be able... no. I was going to say we might be able to get away without indexing, and I think we could, but the problem with it is that right now we have C array, color array, I think is what that stands for. It has a single int for every pixel. But color converter is expecting to find 3 ints for every pixel, essentially. It's expecting to find RGB values, hex RGB 8-bit color values. If we could, instead of having a single 0 to 255 value, so basically if we could convert CR to, instead of just 0 to 255, like grayscale color, essentially, if we could convert that into having the full 3 values for each like pixel, having red, green, and blue for each pixel, then we could use a color converter instead of a palette. And that would mean we don't have to spend time indexing it, which in our case means we don't have to loop over every pixel again. I assume is on the slower side. But I have been blabbing instead of coding so that we can actually measure it. Though it did look like by far the dithering was the slowest part. Not really much to look at. Oh, there's 50 to look at, but... Is it actually? Well, it refreshes at the very end. Dithering, yeah, dithering took about 30 seconds. There's the refresh. Indexing did take another almost 9 seconds. So, I mean, if we could lop off that 9 seconds for indexing, that'd be pretty nice. The loading is not so bad at under a second. The dithering, I don't know that we're going to get a whole lot better at the Python level. I wonder what is the slowest part in here. So one thing that is happening is no, that's a single value. I was gonna say, isn't this is operating on the whole row, but that's not actually the case. It's operating on a single value. So my gut instinct is presumably this is like probably the slowest part of this, but I don't know that there's much. I don't know that there's really much we can do about that. Ultimately, the goal would be, though, to get this into bitmap tools, and then this could be C code and presumably, hopefully, go a little faster. Now, that will be tricky because this code is using, like, microlab instances of stuff. I don't know how easy that's going to be to do from C, but maybe we could get away from using microlab arrays. Maybe there's, once we're in C, maybe that's less useful. We could just use a C array, for instance, potentially. If we multiplied here by FFFFF, 6Fs, whatever that is, wouldn't this then be an 8-bit RGB instead of grayscale 0 to 255 and still represent the same colors? Let's try no indexing. So then C array would be holding RGB 888 values, which we're then going to put into dest bitmap, which is dithered. Should have enough to hold it. And then what we'll do is we won't use a palette. Instead, we'll use a color converter. And that does 888 by default. So then if we did dithered bitmap pixel shader, then I think maybe we can get the same visual output without the indexing step. So we shave off about 10 seconds, which is nice, but it is still like 30 seconds, which is kind of a long time. didn't work. Well, you must fit in 1 byte. Is it? Should it be -1? It might need to be -1 because we had 255 instead of 256. I guess we could just do FE, but hard to tell if those are correct hex values or not since they got converted to E notation, but it's still basically how it was, so. That still doesn't work. Bummer. I mean, that's awkward anyway. It shouldn't be... have a 0 there. This is in 04. Oh. Oh. Right. I'm not sure if that will work. It might actually be the case that bitmap tools.arrayblit. This might not work with big values like this. Maybe it really wants to be indexed, actually. I mean, if this is true, why is there an overflow why is there an overflow exception? To just modulo to count to get it in range. Oh, that finished, but it looks weird. It's different. Interesting. Definitely doesn't look as good. We not have done this? It did. Yeah, I mean, it did still take 30 seconds, and we basically we did cut off the 10 seconds of the indexing. If we could get this to work, it would be nice. No, same. Interesting. Well, I mean, now I think now the problem might just be a rounding and a float math problem, right? Like, yeah. Why would that look too bright, though? That wouldn't look too bright. That should look too dark. No, 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 no. Yes. It should look too dark. Hmm. Has it not used the black? No, it used the black. I don't think it used the dark gray, though, actually. I don't think it used the dark gray. So I think what has happened, actually, is lots of pixels that would have been dark gray got rendered as light gray instead, which makes the whole thing appear overall lighter. And I don't exactly know why that would happen, but my best guess is that because of the way we divided this down and then 565, we're still doing 565 conversions, right? So my rough, like, basic assumption is that we get values between 0 and 255 here. We put them in the buffer. We divide them all by 255 here. So now after that, inside of array, we have values 0.0 to 1.0. But they're floats, which means like they're limited in precision. They can't be precise all the way. Like some of them might end up being wrong because of the precision. When we then go to multiply it back out, those precision errors essentially make it so that when we get to these big hex values, they can be quote unquote wrong. They're coming out as not what we're expecting, essentially. So like here, I think we would be expecting all fives. 555, 555, but instead we're getting 555, 550. And I'm assuming we're having a similar thing take place with other values as well. And I don't get why it would result in all of the dark gray pixels using light gray instead. But I kind of think that that is what has happened. Because I don't actually see any dark gray in this. There's actually only 3 colors in this. There's light gray, there's black, and there's white. There's white on the New York and on the tip of his nose there. And like a little bit down on his lips, I guess, maybe. And on his chain as well, a little bit. And his fingertips. There's light gray on kind of like most of his face, sort of in here. This is all light gray. And then over here where it's darker, it's light gray and it's been shaded with black. And even like down here on his shirt, it's also light gray and it's been shaded with black. It looks like dark gray, admittedly, in this VLC window here. But up close, it is actually light gray shaded with black pixels. So I'm thinking that somewhere in there, the rounding essentially has made our dark gray collapse into our light gray. We're just not quite dark enough in the color we're coming up with for it to choose the correct shade. But like I said before, I don't really get like why that's happening. Because if we imagine this being 5550, it's closer to black. You would think if it were going to get misappropriated, it would get misappropriated into the black color by the color converter, essentially. Because internally, the color converter is going to find, of the 4 colors it can draw, which one to use. You would think it would be not the light one. Or you would think it would be the dark gray accidentally getting treated as black instead of the dark gray accidentally getting treated as the light gray. Since it's ending up with a value that's too low rather than a value that's too high. What is this one? Interesting. Yeah. I mean, that's my best guess as to why it's doing it, but again, I still don't get why it would be rounding. It seems like it's rounded up instead of down, which is very odd since it's actually missing the, it should be like this one is F short, right? It's in hex, it's F amount short. This one is A amount short. This one is 5 short. Which is closer to black. So it should be darker than lighter, but I don't know. It's close. And it's not completely wrong, so that's good. But the color converter one, not quite working. That one would still take some more doing. But the indexed one is actually working. So if I switch this back, this, and I switch this back to multiplying by 255, Is 255 squared is FFFF, right? Or no? $56 squared is F? 55 squared is nowhere near FFFF. Have those... Am I only doing... Only 6 Fs there. Okay. Well, if we put it back to this, we can at least get back to the one that works. And then I think I'll wrap it up for now. This is kind of... maybe slowed down a little bit. I feel like it was hanging a bit more than it was before. And it's definitely a little slower than it was before. But it is also still better than it was at its worst, so that's good. One thing that would be cool is if we could avoid... Like, maybe we could rewrite this algorithm to actually just go ahead and update the value to the indexed color. Oh, I didn't turn back on the indexing. Wonder what this looks like. Ooh, interesting. It's like... I don't know. Inverted? Kinda? I guess it's like inverted. That's kind of cool looking. It's inverted, and it also is only 2-color dithered. It's white and black dithered. Interesting. Do this instead, though. Well, it's not actually perfectly inverted, though, because it's still dark up in here. I don't know what it is. It's only showing the black pixels, and all the rest of the pixels are white. Anything that would be not black is white. Well, no, because the white... I don't know. Maybe it is inverted. I don't know why it would be inverted. Anyway. But maybe there's some way that in the dithering, we can actually just dither directly to a indexed image. I've broken it. How did I break it? How did I break it? Shouldn't have kept messing with it. Did we change the divide? The divide is fine. I don't... Oh. Yeah. So for indexed, we need to... You need to convert them to ints? Actually sure why we need to do this. It doesn't work if we don't, so we'll keep it. All right, 30-second dither. There we go. Yeah, that's a good one. That's using all the colors. Okay. All right, so we made it to palette indexed, I should say. Dithered, 4 colors, looking good. Takes a very long time. At some point, I may try to add it to bitmap tools, but I'm not sure. This might be kind of challenging for me to do in C. But it's always good to do something that's challenging as well. I would definitely love to get rid of the indexing step. And I feel like that should be possible because I mean, for one thing, I wonder if it's possible. Can we just, is there a way we could just not do this and not do this by changing the math inside of here? I assume the math inside of here is all assuming 0 to 1 values. But could we like add some times 255s in here and then get rid of this and then also not have a need for this? And then also, as a last step here, after we've calculated everything, could we then just do this directly in here and then store the indexed int instead of storing the actual color, converting the actual color by multiplying it by 255, and then looping over the whole thing and turning the color into the indexed value? I wonder if we could take out all those steps and do it all in here. I don't know that these are particularly slow, but I assume they're slower than if we didn't have to do them. Maybe not, though. I'm not sure. Okay, but we got pretty far. C. Grover says, thanks for the stream. Discussion of index versus color converter is interesting. Appreciate the reminder that Python variable names are pointers to objects. Yeah, definitely. Not the objects themselves, the value trips me up occasionally. Yep. Me too, as you have seen. All right, I will head out for now. Thanks for watching, everyone. I hope you all have a good rest of your day. Good weekend. I should be back next week at the normal times, I do believe. Deep dive on Friday at 4 p.m. Central, 5 p.m. Eastern, 2 p.m. Pacific. Saturday stream here on my channel, 10 a.m. Central. Should be back for that. Hope you all have a good day, and I will catch you next time. See you later.